Section 5.7 continued, completing the square. In the first part of this section, we work with quadratics in the form of x squared plus bx plus c equals 0. And in this form, our quadratic term had a constant that is a positive 1. In this section, we're going to work with the form of ax squared plus bx equals c. In other words, what we're going to first do is isolate our constant on one side of the equation. So we're going to add or subtract our constant to get it on the other side. But my real concern is the coefficient of my quadratic term is not a positive 1. And we need to get this coefficient of my quadratic term to be a positive 1. To do that, what we're going to do is multiply both sides of the equation by the reciprocal of the coefficient of the quadratic term. So you can see, if it's ax squared, I'm going to multiply both sides by 1 over a. And when I distribute, when I multiply 1 over a times a, that will make this a positive 1. Then, after we distribute and also simplify the right side, we want to continue with our procedures of completing the square to solve for x. In my first example, they want me to solve each equation by completing the square. Here I have 2x squared plus x minus 6 equals 0. I need to isolate my constant onto the opposite side, so I'm going to add 6 to both sides. That gives me 2x squared plus x equals 6. Now I need to get the coefficient of my quadratic term equal to a positive 1, so I'll multiply by the reciprocal of the coefficient, which is going to be 1/2, times 2x squared plus x equals 1/2 times 6. Then I'm going to distribute. When I do, that gives me x squared plus 1/2 x equals 3. I know that the b is equal to 1/2. I need b over 2, which is equal to 1/2 divided by 2, which means I'm going to take 1/2 times 1/2, which is 1/4. And then I need b over 2 squared. And that's going to give me 1/16. So I'm going to add that to both sides of my equation to balance the equation. That gives me x squared plus 1/2 x plus 1/16 equals 3 plus 1/16. The equation is balanced because I added 1/16 to both sides. Now I need to factor my perfect trinomial. That's going to give me x and x. And 1/16 is going to be 1/4 and 1/4. And positive will give me plus plus. And I know that 1/4 times 1/4 is 1/16. 1/4 x plus 1/4 x gives me 2/4, which is 1/2 x. And on the right side, I have a common denominator of 16. So I'm going to multiply the top and bottom by 16. That gives me 48 over 16. 48 plus 1 is 49/16. Then a product of factors can be written as x plus 1/4 squared equals 49/16. Take the square root of both sides, and I get x plus 1/4 equals plus or minus square root of 49 is 7, and the square root of 16 is 4. Now I can make two equations out of this. My first, x plus 1/4 equals a positive 7/4. Subtract 1/4 on both sides. I'll get x equal to 7 minus 1/4 is 6/4, which can simplify to 3/2. And my second equation can equal x plus 1/4 equals a negative 7/4. Subtract 1/4, x equals a negative 7/4 minus 1/4 is going to be a negative 8/4, which is a negative 2. Therefore, my solutions are a negative 2 and 3/2. As we work through this chapter, we realize that there are multiple ways to solve quadratic equations. We solved them by factoring, by graphing, by square roots, now by completing the square. The easiest way to solve this problem is by factoring. And I put that problem on the previous page so we could show you the process of solving this by completing the square. But I would actually solve this by factoring if I was given the problem. But I will solve this by factoring now just to verify the solutions on the previous page. Also to show you that if I recognize certain patterns, I can make solving these problems quicker just by determining that I can factor this rather than by completing the square. So here, if I factor, I can set up a product of two binomials, and I know this will be 2x and x, and I can break this into 3 and 2. This is a minus sign, so I need a plus, minus, minus, plus, but I need a positive middle term. So I'm going to set this up to be a minus plus. Now, if I'd FOIL, that would give me 2x squared minus 3x plus 4x. That would give me 1x, and of course, I have my minus 6. Then if I solved each equation, that would give me 2x minus 3 equals 0, 2x equals 3, and x equals 3/2, and x plus 2 equals 0, x equals a negative 2. And these are the solutions we got on the previous slide. They just got to be a lot quicker when we know that we can factor them. I did that process on this problem because I wanted to show you the completing the square and also to verify that we could get the same solution by factoring. We'd get the same solution by graphing also. Again, they want me to solve each equation by completing the square. Here I have a negative 2x squared minus 4 equals a negative 3x. I need my quadratic and linear term on the same side of the equation. So I'll add 3x, and I need my constant term on the opposite side, so I'll add 4. That gives me a negative 2x squared plus 3x equals 4. I need the coefficient of my quadratic term to be a positive 1, so I'll multiply both sides by the reciprocal, which is a negative 1/2. And when I distribute, that's going to leave me with x squared minus 3/2 x equals a negative 2. Now I need to complete the square. B is equal to a negative 3/2. B over 2 is equal to a negative 3 over 2 divided by 2, which equals a negative 3 over 2 times 1/2, which we know equals a negative 3/4. I need b over 2 squared, which equals negative 3/4 squared is a positive 9/16. I'm going to add that to both sides of my equation, so it balances my equation. That gives me x squared minus 3 over 2x plus 9/16 equals a negative 2 plus 9/16. Perfect trinomial, I can factor into a product of its two binomials. That gives me x and x. This will be 3/4 and 3/4. Since this is plus plus, I either need plus plus or minus minus. Since this is negative, it'll make it minus minus. That gives me a negative 3/4 times a negative 3/4, which is a positive 9/16. But a negative 3/4 x minus 3/4 x is going to give me 6/4. But when I simplify 6/4, that'll be 3/2. On this side, a common denominator is going to be 16. I'll multiply the top and bottom of this by 16. That gives me a negative 32 over 16. A negative 32 plus 9 is going to give me a negative 23 over 16. I can rewrite this as x minus 3/4 squared equals a negative 23 over 16. And when I square root on both sides, that gives me x minus 3/4 equals plus or minus the square root of a negative 23 over the square root of 16, which we know is 4. But this simplifies plus or minus, and this breaks into a product of factors, a negative 1 and 23. The square root of a negative 1 is I. Square roots of 23 over 4. And we know this is an imaginary number, and therefore I don't have any real roots. But I can still create my two equations. My first, x minus 3/4 equals a positive I square roots of 23 over 4. Add 3/4 to both sides, gives me 3/4 plus I square roots of 23 over 4. My second one, x minus 3/4 equals a negative I square roots of 23 over 4. Add 3/4 to both sides, I get x equal to 3/4 minus I square roots of 23 over 4. So I have two imaginary solutions. So when I graph, this graph does not intersect the x-axis, and since this is negative, it's actually pointing down. On previous sections, we learned how to graph quadratic equations by using the axis of symmetry and also by finding the vertex. It's a lot easier to graph quadratic equations if we put it in a vertex form. So if we're given a standard form, we must complete the square to put it in a vertex form. So we're given y equals ax squared plus bx plus c, which is our standard form. And we want it in vertex form, which is y equals a times the quantity of x minus h squared plus k. And we know that hk is the vertex of my parabola. All we need to do is complete the square on my standard form to get it in this form. Let's look at the procedure to write a quadratic in vertex form. 1, I want to group the quadratic and linear term with parentheses. 2, I want to get the coefficient of the quadratic term to be a positive 1 by factoring. Number 3, I want to complete the square. Number 4, I want to add b over 2 squared to the group and subtract b over 2 squared on the outside of the group. This is done except when you factored the coefficient in step 2. When this occurs, we have to follow a different procedure, but we'll take a look at both in our examples. Number 5, then I want to factor the perfect trinomial. Here's our first example. I want to rewrite each equation in vertex form, then determine the vertex. So what I want to do is group my quadratic and linear term. Y equals x squared minus 10x minus 2. I want to complete the square. I can do that because I know my coefficient of my quadratic is a positive 1. That gives me, when I complete the square, x squared minus 10x. B is a negative 10. Negative 10 divided by 2 is a negative 5. And when I square that, that's going to be 25. I want to add that to my group. And since I did not factor anything out, I want to subtract that outside of my group, which is a negative 2 minus 25. Now I want to factor my perfect trinomial, x minus 5 and x minus 5. And when I simplify, minus 27. And then I rewrite x minus 5 squared minus 27. Now I can determine my vertex because this is in vertex form. So my vertex is h, comma k. My h is 5, and k is a negative 27. And I know that my vertex is to the right 5 and down 27. And since this quadratic is positive, it will open up. Also, remember, since this is in vertex form, my vertex form has the minus sign here. To keep this a negative, my 5 has to be positive. Therefore, h is positive, and that's why it's 5, negative 27. Again, on this example, they want me to rewrite each equation in vertex form, then determine the vertex. I want to group my quadratic and linear term, y equals 2x squared plus 6x minus 3. I want to factor to get my coefficient of my quadratic term to be a positive 1. So y equals, I'm going to factor out a 2, leaving me x squared plus 3x inside my parentheses. And I only factor what's inside my grouping. Now I want to complete the square. Y equals 2 times the quantity of x squared plus 3x. B is 3. B divided by 2 is 3 over 2. When I square that, that's going to give me 9/4. I always add b over 2 squared to the interior of my group. So I'm going to add 9/4 to the group. And I need to subtract that value on the outside. But recall in my procedures that there was an exception to the rule, and that is when I have factored my coefficient out on a previous step. So essentially, I added 9/4 to this group, but if I would distribute back in, I really didn't add 9/4. I added 9/4 times 2, which would give me 9 over 2. So what I have to do is subtract the same value on the outside. To do that, I'm going to subtract 9/4, which is a negative 9/4. I'm going to multiply by what I factored out, which is 2. And when I multiply, that's going to give me a negative 9/2. So I'm going to subtract 9/2 on the exterior of the group. So remember, I can add b over 2 squared to the interior of the group at all times, but I have to be careful what I subtract on the exterior. It all depends on what I factored out. Now I can factor my perfect trinomial, y equals 2, my 2 sets of parentheses, x and x. 9/4 will break into 3 over 2 and 3 over 2, and this will be plus plus, and 3/2 times 3/2 is 9/4, but 3/2 x plus 3/2 x is 3x. And when I simplify on the outside, my common denominator is 2, which gives me a negative 6/2, which gives me a negative 15/2. Then I can rewrite my binomials, x plus 3 over 2 squared minus 15 over 2. Now I can find my vertex. This is in vertex form. And I know in vertex form this has to be a minus sign. But to change this to a positive must mean my h is negative. So this is h k, and my h has to be negative since that's positive, which is a negative 3/2, comma, negative 15/2. I know that this would be to the left 3/2, down 15/2, and then my graph would open up because my quadratic is positive. Again, I want to rewrite each equation in vertex form, then determine the vertex. So what I need to do is group my quadratic and linear terms. So I'm going to have y equals a negative 3x squared minus 4x minus 2. I need the factor to get my coefficient of my quadratic to be a positive 1. So y equals, when I factor out a negative 3, that gives me a positive x squared. Essentially, I want to divide this by a negative 3, which would make that a positive 4/3 x, then minus 2. I can check that by distributing. So a negative 3 times x squared is a negative 3x squared. A negative 3 times a positive is a negative. The 3's cancel, and it gives me a minus 4x. Now I want to complete the square. Y equals a negative 3 times x squared plus 4/3 x. B is 4/3. I want to divide that by 2, so it's 4/3 divided by 2, which is 4/3 times a half, which is 4/6. But when I simplify, 4/6 will simplify to 2/3. When I square 2/3, that's 4/9. Remember, I can always add b over 2 squared into my group, which is 4/9. I need to subtract that on the exterior of the group, so minus 4/9. And remember, that's the exception to the rule. If I factored something out, I really didn't add 4/9 to this. I added 4/9 times a negative 3, which is a negative 3 times 4/9, which is a negative 4/3. I need to subtract that value on the outside, so a negative 4/9, and I'm going to multiply times that factor, which is a negative 3. And when I do, that's going to give me a positive 4/3. So this is positive. So even though we said subtract, when I multiply by a negative, that's going to give me a positive 4/3. Now I can factor my perfect trinomial. Y equals a negative 3 times x and x. And this will break up into 2/3 and 2/3. And since this is positive, it'll be plus, plus. And when I simplify on the exterior, my common denominator is 3. 3 times 2 is 6/3. And a negative 6/3 plus 4/3 is a negative 2/3. Let's rewrite this. So y equals a negative 3 times x plus 2/3 squared minus 2/3. And that is my vertex form. And now I can find the vertex. And we know that the vertex is h, comma k. And here, my vertex form should be negative. And since it's not, that means my h must be negative. So that's a negative 2/3. And that's a negative 2/3. And this would be to the left 2/3 and down 2/3. And it would open downward because my quadratic term is negative. On last examples, they want me to find the value of k that would make the left side of each equation a perfect trinomial. Here, all I have to do essentially is to factor this. This would be x and x. And this would break up into 6 and 6. And I know this is either going to be a plus sign and a plus sign, or a minus sign and a minus sign. If it's plus and plus, that would make this a positive 6x, and a positive 6x would make that a positive 12x. So k could be a positive 12. Or if they were both negative, it would be a minus 6x and a minus 6x. It would be a negative 12. So there would be a plus or minus 12. Again, over here, I want to factor the perfect trinomial. This would be 3x and 3x. This would be 5 and 5. And again, this could be plus, plus, or minus, minus. If it was plus, plus, that would give me a positive 15, and a positive 15x would give me a positive 30. Or if it was minus, minus, it'd be a minus 15, and a minus 15, which would be a negative 30. So k could either be a positive or negative 30. Just remember, that I broke up 9 to 3 and 3 and 25 to 5 and 5, and also at 36, 6 and 6, because I have a perfect trinomial, which means I know that these have to be perfect squares and they have to break up into those perfect squares.